Welcome to this session on Relational Database Management System. My name is Ashish Jain. I am an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. Our today's topic is functional dependencies. We start with the introduction with functional dependencies. We will see what are the different types of functional dependencies that we have. We will see some advantages of functional dependencies as well as the limitations of functional dependencies. Before we start our topic, functional dependency, I just give you a real life example where we can use this concept of functional dependency. Suppose that a person went to a shopping mall to get some items for the home grocery, you can say. So he bought different items, and whenever he go to a cashier just scans the barcode of different products that he has bought and come up with a bill. Now with that bill, the computer can determine that whether how many number of items have been purchased, so that we can have multiple number of times the billing of that product. Similarly, if you go to a big library and you want to search for a particular book, instead of searching from different floors and different shelves, it's better to search it on computer system, wherein you just have to write the name of the book or author or any other information you have. Based upon that information, whatever details are there for a particular book can be searched easily. All this is possible because we maintain the data in terms of tables or tabular representations, and we have a relationship among different fields in that table. This dependency, relationship among different attributes in a database is known as functional dependency, and it is a very important topic when you learn or understand the concepts of DBMS and how DBMS is actually created and maintained. So here we define functional dependencies. In RDBMS, we can define functional dependency as a relationship between different attributes of any table that are dependent on each other. So it shows that how the values in one or more tables or attributes determines the value in the another. This concept has been given by E.F. Codd, who is regarded as the father of DBMS. This typically exists between the primary key and the non-primary key. In a table or a relation, we have some key attributes, and generally the most frequently used key attribute is the primary key. So we have the relationship between the primary key and all those fields that are non-primary. It is very essential for maintaining data integrity and building effective, organized and normalized databases. This is the use of functional dependencies. So we denote functional dependency numerically or mathematically using a notation which use an arrow symbol, which is also called arrow or production. So we say that a functional dependency x on y, it is represented as x arrow y. That means y is functionally dependent on x. We read this line from right to left. It is y is functionally dependent on x. This notation has two components, a left hand side part or the LHS and the right hand side part. The left hand side part is called determinant and the right hand side part is called dependent. So y is a dependent variable and x is an independent variable. If you see the representation here, x is called determinant because x determines the value of y, and the value of y is based or dependent on the value of x. So we say that y is functionally dependent on x. Suppose this is a table in which we have 4 fields or 4 attributes: roll number, name, age and GPA, right? Here roll number is a primary key attribute. We can have name as common, we can have age similar to two students, we can have their GPA is same, but their roll number should be different, right? So roll number is a prime attribute or a primary key. All the rest keys that are not prime are called non-prime attributes. So we basically establish a relationship between a primary attribute and a non-primary attribute using functional dependencies. We can take another example. This is a table having 5 columns. We have ID, name, age, city and phone number. Here each individual will have a unique ID. So this ID field is a primary key or a prime attribute of this relation or table. The name field, 2 persons can have same name, right? But a name is bounded to a particular ID. This Luke is bounded to ID 67, another person having the same name but the ID is different, right? So this is a non-prime attribute. Similarly, age, 2 persons might have same age, so it is also a non-prime attribute. Prime attribute doesn't have any repetitions in their values. City, two persons might be living in the same city, right? So they are also non-prime attributes. Also phone number. Generally we believe that no two persons will have same number, but there may be chances that they share the same number, so it is non-prime attribute. So hence in this table we only have one prime attribute and rest 4 non-prime attributes. Coming to the types of functional dependencies, we have 4 types of functional dependencies in general. First is called trivial dependency, then we have non-trivial dependency, then we have multivalued dependency, and we have the transitive dependency. Let us see them one by one. First we look at trivial dependency or trivial functional dependencies. In short, we can say functional dependencies as FD. In a trivial functional dependency, a dependent is always a subset of determinant. That means the variable which depends on the value of a determinant is always a subset or a part of that whole thing or whole value of the determinant. In other words, we can say that the right side or the LH or the RHS is a subset of the attributes of LHS. We say that if we have a functional dependency, say x tends to y or x arrow y, this is trivial when y is a subset of x. That means the value of y belongs to or inner part belongs to the values of x. For example, we have a table in which we have these columns as employee ID, name and age. These are the values here. Here the employee ID, employee name is a primary key which is constructed using just 2 fields together. It is a composite primary key, and on the RHS side we have just name. Here if you notice, the value of name is a part of the value of your primary key because it is formed by 2 fields. So name is a subset of this set. Subset means part. Hence this relationship, which is employee ID comma name tends to name, is a trivial functional dependencies. Okay. Then similarly we have employee ID. Every field is a subset of itself. So employee ID tends to employee ID is a trivial dependency. Similarly name tends to name is also a trivial. Age tends to age is also a trivial dependency. The next dependency is non-trivial functional dependency. Non-trivial dependency exists when a dependent variable is not the subset of the determinant variable. In other words, we can say that a functional dependency is non-trivial if the attributes on the right hand side are not the subset of the attributes on the left hand side. For example, again we have x tends to y as a functional dependency. This is called non-trivial if y is not the subset of x. In the previous case, in trivial, y is a subset of x, but in non-trivial, y is not the subset of x. Again we have the example here. So employee ID tends to name. Since name is not part of the left hand side, this is not a trivial dependency. Hence we say that this functional dependency is non-trivial. Similarly, employee ID name tends to age. Since age is not part of the left hand side determinant, we say that this dependency is also non-trivial. Then we have multi-value functional dependency. Multi means many. So it have more than one values. In multi-value functional dependencies, attributes in the dependent set are not dependent on each other. So if we have more than one attributes or more than one values in a dependent set on the RHS, they both are not subsets of each other. For example, if we have a functional dependency, say x tends to y comma z. So if there exists no functional dependency between y and z, they are mutually exclusive, then we say that it is multi-valued functional dependency. For example, consider this table. We have employee ID, name and age. Here employee ID tends to name comma age is a multi-value function because age does not depend on name or name does not depend on age. They are mutually exclusive. Hence we say that this is a multi-value dependency. Next we have transitive functional dependency. In transitive functional dependency, the dependent is not directly, but it is independently dependent on the determinant value. Here for example, we have 2 functional dependencies, A tends to B and B tends to C. From this, according to the transitivity axiom that we have in set theory and other mathematical forms, if we have values A tends to B and B tends to C, then from this we can infer that A tends to C. That means C is not directly connected with A, but indirectly it is dependent on A. This type of relationship is called transitive relationship. We'll take an example here. Here employee ID tends to department, that means department is dependent on employee ID. Similarly, street number is dependent on department. Here, since the department field is common in both, one from the left hand side, other from the right hand side. So, we can say that the dependency we have employee ID tends to street number, that means street number indirectly depends on employee ID is a valid functional dependencies, and for this reason this is considered as transitive functional dependencies. So, we have seen 4 types of dependencies. First one is trivial, second one is non-trivial, then we have multivalued, and this one is transitive. Now, let us see with an example how do we find functional dependencies in a relation if it is not given explicitly. Suppose we have a table named student, in which we have 6 different columns or attributes. We have student number, student name, student phone number, state, country and age with some data attached. Now, we know that student number is unique because student does no 2 students can have the same number. We can consider this student number as a roll number or an enrollment number which is unique for every student. So, in this case we consider the student number as a primary key attribute. Now, we see that student number tends to student name, student number tends to phone number, student number tends to student state, student number tends to student country, as well as student number tends to student age. All will be true because all the non-key attributes will be dependent on the value of this key field, which is student number. Similarly, we can say that student country depends on the value of student state. It is true. If 2 records have same state, yes, and they will also have same country. For relations, student course number tends to course name. It is also true as both these 2 records will with same course number will have the same course name, because one course will have only one course number, right. So, in this way, by seeing the values that are in the table, we can also form functional dependencies if they are not explicitly given to us. Now, let us see what are the advantages of having functional dependencies or using a functional dependencies in designing effective databases. The first and foremost is that functional dependency avoids data redundancy. It means duplication of data. Therefore, the same data do not repeat at multiple locations in database, so that our data is in consistent state and there will not be any ambiguity in our data. That means functional dependencies is essential to avoid redundancy in data. Second, it helps to maintain the quality of data in a database. As our data is properly managed and are linked with the related keys, our data is of a good quality. Also, functional dependency guarantees that the data is correct, it is consistent throughout a database. In whichever form we take the data, the value of the data is true, so that you can take it for your work. It also enhances integrity of data as the data is properly integrated in whichever form or whichever way you use it. Next is functional dependencies helps to define the meanings and constraints of databases. Since we bound the values of attributes using a key variable, so it helps to impart some kind of constraints on data so that we do not accidentally change the data, and it is very good so that we can draw some kind of information from the database very easily if we have a proper data that is managed through functional dependency concepts. Also, it helps to identify bad designs. If you do not imply the rules of functional dependencies while designing a database, you may end up building a database which is very inconsistent, which cannot be used properly for getting the result at the right time. So, this is considered as a bad design. So, using functional dependencies, you can also identify which databases are designed poorly or having a bad design. Also, the use of functional dependencies makes our work simpler. We can add, edit and remove data easily. That helps in proper effective database management. So, all these are advantages or benefits of functional dependencies that we have. Next, we will see some limitations of functional dependencies. The first limitation that we have for functional dependency is The process of identifying the functional dependencies can be time consuming and complex. As we have seen in the previous example, since we only have 6 fields, so we can do it easily, but in real sense there are more than 20-30 columns or many columns in a database. So to get what are the functional dependencies are there in the database, it's very tough and it becomes complex at times, especially for large databases that have many tables and many relationships among them. Also, overly restrictive functional dependencies can result in slow query. Since we have interrelationship among various fields, so to get the data at the right time, it requires a considerable amount of time, so your query will be processed a bit slow. Then functional dependencies do not take into account the semantic meaning of data and may not always reflect the true relationship between data elements. So there may be chances that they're not in real life, there is no relation between those two fields, but logically we can have a relationship in database, right? So it does not take the logical relationship but only syntactical relationship. That's why semantic relationship or meaning of data cannot be conveyed every time properly using functional dependencies. This is a drawback of it. So at last, let us sum up what we have seen in this module. We started with the introduction of functional dependency. Second, we have seen different types of functional dependencies. We have seen the advantages of functional dependencies and also looked for different limitations of functional dependencies. I hope this introductory session on functional dependency is beneficial for you. In the coming session, we will be looking at different ways of solving functional dependency problems and making the database design simpler. Thank you for joining. Happy learning.